Assalamu alaikum, Midline Properties Part 1. At the end of this video, students will be able to recognize that the straight line passing through the midpoint of one side of a triangle and parallel to another side passes through the midpoint of the third side. Recognize that the segment joining the midpoints of two sides of a triangle is parallel to the third side. Materials: paper, pencil, ruler, compass, protractor, and your textbook edition 2012 or 2017. Prerequisites: two lines are said to be parallel if they never meet. That means there is no point of intersection between them. L and S, they never meet, then they are parallel. L is parallel to S. If two lines are perpendicular to the same straight line, then they are parallel. Here we have L and S, both perpendicular to the same straight line M, then L is parallel to S. We write L perpendicular to M, S perpendicular to M, then L is parallel to S. Lines joining the midpoints of a triangle. Midline theorem in a triangle. Activity: draw a triangle EFG such that EF equals 4 cm, FG equals 3 cm, and EG equals 6 cm. Let M be the midpoint of EF. Draw a line D passing through M and parallel to EG. D cuts FG at P. 1. Using measurements, what does P represent to FG? 2. Complete. In the triangle EFG, if M is the of EF and MP to EG, so P is the of FG. Please pause the video and try to solve this activity. Solution. Here we have to the right the figure EFG. We have M is the midpoint of FE and D is the line parallel to EG passing through M. P is the point of intersection of D and FG. First question: what does P represent to FG by measurements? By measurements, FP is equal to PG is equal to 1.5 cm, then P represents the midpoint of FG. Of course, we have FP and G are collinear points because we cannot talk about midpoint of a segment if the 3 points are not collinear. 2. Now, from the given above and from the conclusion in part 1, we have to complete part 2. In the triangle EFG, if M is the midpoint of FE, of course M is the midpoint of FE, and MP is parallel to EG, also from the given we have MP is parallel to EG, then from part 1 we get that P is the midpoint of FG. So if M is the midpoint of EF and MP is parallel to EG, then P is the midpoint of FG. Midline theorem in triangle. A line passing through the midpoint of one side of a triangle and parallel to the line holding to another side passes through the midpoint of the third side. This theorem is called midline theorem. Let's see this theorem using the previous figure. In the previous figure, we have a triangle EFG. We have M is the midpoint of the first side. D is the line passing through this midpoint and parallel to the second side. We get that the point of intersection of the third side with this line is the midpoint of the third side. So, a line passing through the midpoint of one side, which is D, passing through the midpoint of EF, which is M. And parallel to the line holding to another side, D is parallel to the line holding to the another side, which is EG, passes through the midpoint of the third side, so it passes through P, the midpoint of FG. This is a general theorem, midline theorem, can be applied on any triangle. If we have any triangle and we have the midpoint of the first side, a line passing through this midpoint and parallel to the second side, then it will pass through the midpoint of the third side. Here we have in triangle EFG, M is the midpoint of EF, MP is parallel to EG, so by midline theorem, P is the midpoint of FG. Then in any triangle, using midline theorem, we need one midpoint and a line passing through it and parallel to the second side, we get the second midpoint, the midpoint of the third side. Application. ABCD is a rectangle of center O. L is a line perpendicular to BC at H and passing through O. Show that H is the midpoint of BC. So here we have a rectangle ABCD. O is the center of this rectangle. L is a line passing through O and perpendicular to BC at H. Please pause the video and try to solve this application. Solution. First, in order to solve this application, we have to use midline theorem, of course. Midline theorem is applied on triangles. We took midline theorem in triangles. So we have to choose a triangle in order to apply the theorem on this triangle. Okay, we have to show that H is the midpoint of BC. So we can choose triangle BCA or triangle BDC. I will choose triangle BDC. We will apply midline theorem on this triangle. So in triangle BDC, what do we have? Let's remember, in order to apply midline theorem, we need a midpoint of the first side, a line passing through this midpoint and parallel to the second side, and we will get that this line passes through the midpoint of the third side. Where is the first midpoint here? Yes, we have O. O is the center of ABCD by given, then O is the midpoint of BD. Now we got the midpoint, we need a line passing through this midpoint and parallel to the second side of the triangle. Clearly from the given, L is passing through O, and we have to show that L is parallel to DC in order to apply the theorem. How to show that L is parallel to DC? Let's remember from the prerequisites that if we have two lines perpendicular to the same straight line, then these two lines are parallel. We have L is perpendicular to BC at H given. Also, DC is perpendicular to BC at C, adjacent sides of a rectangle. Then L is parallel to DC, two lines perpendicular to the same straight line are parallel. And since we have BH and C are collinear, hence we can apply midline theorem. By midline theorem in triangle BDC, H is the midpoint of BC. We will move to the second objective, converse of midline theorem in a triangle. Activity. ABC is a triangle such that AB equals 3 cm, BC equals 5 cm, and AC equals 6 cm. Let M and N be the respective midpoints of AB and AC. 1. Reproduce the figure with exact measure. 2. Measure using a protractor the angles AMN and ABC. 3A. Compare the measures of the angles AMN and ABC. B. Deduce the relative position of BC and MN. Please pause the video and try to solve this activity. Solution. First, we have M and N are the respective midpoints of AB and AC. 1. We have to reproduce the figure. The figure must be like the figure here to the right. 2. We get AMN equal 94 degrees using a protractor. Also ABC equal 94 degrees using a protractor. Part 3a, compare the measures of these two angles. They are equal. Part B, we have to deduce the relative position of BC and MN. Since angle M here is equal to angle B here, and they are two corresponding angles, then MN is parallel to BC by corresponding angles. So what is the conclusion from this activity? What do we notice? First, we have two midpoints. The first midpoint here and the second midpoint here. We have two midpoints of two sides of a triangle. We concluded that MN is parallel to BC. Converse of midline theorem in a triangle. The line segment joining the midpoints of two sides of a triangle is parallel to the third side. As we see here, like in the previous activity, we have first D is the midpoint of AC, E is the midpoint of BC. We deduce that DE is parallel to AB by midline theorem. So here in triangle ABC we have D is the midpoint of AC, E is the midpoint of BC. So using converse of midline theorem, DE is parallel to AB. This segment DE is called midline segment. Remark, a midline in a triangle is a line joining the midpoints of two sides of a triangle. Therefore, a midline in a triangle is a line joining the midpoints of two sides. This line is always parallel to the third side by converse of midline theorem. Application. EFGH is a parallelogram with center O. L is the midpoint of HG. Show that OL is parallel to FG. So here we have parallelogram EFGH. We have O is the center of this parallelogram. L is the midpoint of HG. We have to show that OL is parallel to FG. Please pause the video and try to solve this application. Solution. Of course, we have to use the converse of midline theorem in order to solve this application. So we have to search for the convenient triangle. OL and FG are in triangle FHG. So we take a triangle FHG. In order to apply the converse of midline theorem, we need two midpoints, the midpoint of the first side and the midpoint of the second side. So first we take triangle FGH. Here we have L is the midpoint of HG by given. Then we have O is the center of this parallelogram. Then O is the midpoint of its diagonal FH. O is the center of parallelogram EFGH. So O is the midpoint of FH. Then by converse of midline theorem, because we have now two midpoints, we can apply converse of midline theorem. We get OL is parallel to FG. We get the line joining the two midpoints is parallel to the third side in this triangle. Hence, OL is parallel to FG. Assignment. Review from the textbook, pages 91 and 92, edition 2012, pages 95 and 96, edition 2017. Homework from the textbook, exercises 2 and 7, pages 96 and 97, edition 2012, pages 101 and 102, edition 2017. Summary. Midline theorem in a triangle. We have the first midpoint and parallel lines. We get the second midpoint. Converse of midline theorem. First midpoint and second midpoint, we get parallel lines. Thank you for your attention.